In this case, you don't have that pit. The excavation is for parking and all, making parking and all. So in these cases, this is how shuttering is provided. Is it clear, guys? Shuttering of footing. Column is erected, footing, these things you can see. If you want, I'll just show you some more photographs. So next we erect these reinforcement. This is footing jali. Correct? This is footing jali, and upon this column is erected. So as you can see here, the PCC comes out of footing area, and the bends you can see here. Correct? Much closer view. So without placing of footing column jali, your footing reinforcement looks something like this. You can see some small stones here. Correct? These stones are nothing but placed for providing spacing. So this is how it looks. These two footings have been taken down for the purpose of lift shaft. Correct? So it is a bit difficult to explain. So here you can see all the footings have been completed with shuttering. Here you can see it is actually isolated footing itself. You can see here the bars, two isolated footings joined. It is not actually combined. So here you can see here, you can't expect to provide cover. We had expected 50 mm cover on the sides, right? So, but as you can see here, there is hardly any cover. Correct? The reinforcement is almost, the shuttering is almost next to your reinforcement. So why I am showing you this picture? Can you see something here? Why is this done? It is top of the column. Why it is done so? Can anybody explain me why this is provided like this? One bar is short, one bar is long. So why is it like that? Here. Hmm. Hmm. Okay. Anybody else is having any answers? Anybody else? Yes, for further extension. Correct, for further extension. That is, we call it something as lapping. Correct. So if I provide like this, my lapping will be staggered. Staggered means it will not be in a single line. So if I do something like this, my lapping will, this bar lapping will start here. Again, this bar lapping will start at the top. So as Gautam said, it will, like it will not create any weak joint in the column. Correct. Since if we do all the staggering at one place, that place will be prone to buckling. I hope you guys are understanding. If I lap all the bars at one single place, it will be prone to buckling because that is where our bars are discontinued and we have tied them. Correct? The strength is not comparatively very high. So in this case, you can see these columns height is being staggered. So I hope it is clear. Next, same footing. So this is concreting in process. Correct? This line you can see here. It is concrete pump in process. I hope you might have seen. So after casting, it looks something like this. Correct? So you guys understood right from PCC till footing in just 2 minutes. I hope so. So the concrete quantities which you have calculated, cement, sand, aggregate, that should be matching these quantities. Correct? These heights you can see. Is clear, guys? Is it clear? Next, we'll go to PCC rate analysis. So as we had done in the last case brickwork, we'll do in the same way. Cement was that was required was 370, and coarse aggregate was required was 0.253. Again, fine aggregate 0.127. Labor rate 1.8 meter square, and these are the rates, approximate rates. This will vary according to your sites. So these are the cost, and I am getting 886 rupees for 0.27 m cube. So if it is 886 for 0.26 m cube, then for 1 m cube it is 886 divided by 0.27. It is 3281 rupees into 20%. What is the 20%? Why I have multiplied 1.2 there? 10% is your profit. That I understood. What is other 10%? The other 10% is basically miscellaneous, yeah, including your wastage, transport, scaffolding, everything. You don't know what expenses may come to you. So that is it. Is it clear? PCC. These rates you can check and you can vary according to your requirements. Next, footing in the same way. Cement that was required was 5 bags, 370, 1850. Coarse aggregate 0.43 m cube. All these quantities are in terms of m cube apart from your cement and shuttering. So 0.36 fine aggregate. Labor concreting 1.5 by 1.2 was our size of the footing. 0.38 was the height. So 0.684. Next, labor shuttering. I hope you guys understood the labor shuttering. So if my footing size is 1.5 by 1.2, on two sides I have to place shuttering. That is why 2 times of 1.5 is the length, 0.38 is the height. Clear, guys? 2 times, because two faces of the footing are going to be of the length of 1.5 meter. So 2 times 1.5 into 0.38 plus the other two sides, 2 into 1.2 into 0.38. So it comes around 2.052 meter square. The rate comes around 223 rupees per meter square. So you are having so much. So for 0.684 m cube, I am getting 3526.9 rupees. So similarly for 1 m cube, I will be getting 5156. For to that I am adding 20%. So 6187 rupees per m cube is your footing rate. Approximately, you can see here PCC it comes around 4000, 3937. You can approximately take it as 4000, and your concrete rate comes around 6200. Is it clear, guys? PCC analysis and footing rate analysis. Clear? And this steel I have taken from your yesterday's calculation only. Steel I have taken, not in this footing. In footing rate analysis, steel will not come. Steel is always considered separately, and that has to be considered as per your yesterday's calculation. Here I have not mentioned that. This is only with respect to your footing, concreting, and labor for concreting. This next one, we'll move on to columns. I hope footing is clear. We calculated number of bars. We calculated number of bars in X and Y direction. Number of total 12 meter bars, how much we require, that we calculated, and then we calculate kg. And in terms of concrete, we calculated what is the amount of cement, sand, aggregate required. Then we calculated the shuttering quantity and our all these quantities, and our including wastage, it comes around 6200. Is it clear, guys? We'll move on to column. Okay, as you know, column is the next structural member which connects our footing. Correct? So when I say concrete column, it basically transfers load from our slab and beam to footing, correct? This is the structural member which carries the load vertically. All others carry load horizontally. This is a member which will be carrying along its axis or longitudinal axis. So you might have studied these things, still I am telling you to revise this. Minimum percentage of longitudinal reinforcement is 0.8, maximum as per IS is around 6%, but it should not be greater than 4%. Around 1.5% is your economical one. Minimum dia of longitudinal bars 12 mm, and minimum number of bars in a rectangular column is 4, and if it is circular then it is around 6. And minimum diameter of it is not stirrups, actually it is ties. Minimum diameter of ties can be 6 mm, but it is preferable to provide minimum of 8 mm. Transverse reinforcement ties, there are three values that you can provide. One is designed value, next one is 16 times D, next one is 300 mm. It is always better to provide ties at 150 mm center to center and not more than 200 mm center to center. Axial load is a major governing force for designing of column. However, in long span buildings, that is around 15-20 feet buildings, there you can like biaxial and uniaxial moments come into picture. Always check interaction equation, it should be less than 1. Most of you may not be knowing interaction equation. We'll learn that when we go for designs. Longitudinal reinforcement in column is placed symmetrical in both x and y direction. For example, 230 by 230 is my column size, 9 inch by 9 inch is my column size. If I split that column in x and y direction exactly at the middle, it should be symmetrical. I hope in my classes I have told, I hope you guys remember. If I split my column half in 4 quadrants, both in x and y direction, all the 4 quadrants should be symmetric. It should not happen that reinforcement placed is unsymmetric. Next, what are the inputs you require for the estimation of column? What inputs you will require for its estimation of column? Yes guys, what are the inputs required? Okay, size I have given 9 inch by 12 inch. Size you can take 9 inch by 12 inch. I will not go into loads, Suraj. Loads will be given, like we are not designing here. We have the cross section and other dimensions. We are just going to estimate. Size you can take it as 9 inch by 12 inch. Just what other these things you need, inputs you need? This load we had discussed, we don't need load. Yeah, one number, just one number. Just one number I need. Okay, orientation is not required for estimation purpose. Just size you have got. Okay, 9 inch by 12 inch. Next, what else you require? Come on, fast everybody. Shape of the column, let us take rectangular, correct rectangular shape. But when I am saying 9 inch by 12 inch, it has to be rectangular only. You should have understood by that. Yes, what about others? Yeah, that is what I am telling, man. We are not bothered about load and SVC. We are not going to design the column. Okay, structure engineer has given you the column sizes and all other requirements. 9 inch by 12 inch is given to you. Reinforcement you can take it as 12 dia 6 bars. 12 dia 6 bars you are having reinforcement. What else you need? Price of steel, it depends on again brand. You can take it approximately around 60 rupees. Yes, guys, what are the other requirements, sir? Yes, do I need a depth of foundation? When I say depth of foundation, it is the level at which my footing is placed, that is below ground level. Do I need it or not? It is not required. Yes, everybody, do I need the depth of foundation? Why I need depth of foundation? Why I need depth of foundation, guys? Because basically my column is going to start from the footing itself, right from footing. So let us take depth of foundation as 1.5 meter. Okay. Now, total height of the building. Let us assume that my building is of only one floor. Okay. My building is of only one floor. So what will be total height of the building? Can anybody just guess? I am having a single floor building, 10 feet height, normal building. So how much is the height of how much might be the height of my building till the topmost edge? Till the topmost edge, what might be the height of my building? Yes, guys, I am having a single floor home. What is the total height of the building? From the existing ground level, I am asking. From the existing ground level, no need to take from foundation level. From the existing level, existing floor level. 15 feet. Okay, 10 feet plus 5 feet. Okay. Then any other answers? From the book knowledge point of view, your answer is right. But practically at site, slightly different. Ajay is saying 14 feet. Okay. Okay, everybody, you can please listen. How do you calculate this? Okay. Why I need this total height of the building is because I have to provide reinforcement right from footing till the total top of the footing. Now, total height of the building, let us assume. Now, I am not providing here depth of the footing. Depth of the foundation, I am not considering. We will take this above ground level. I will write this above ground level. Okay. So, okay. I will write this 1 meter. What is this 1 meter? Above ground level, I am writing 1 meter. What is that? Can anybody just guess? Yes, plinth level, plinth top, correct? Yes, you guys are right, plinth top. Because my existing ground level will be in line with my road level, correct? One should always build his plinth level or your starting point of the door should be at a level of at least 3 feet or 1 meter high from the existing road level. So last time you might have seen flooding in some areas. In Belgaum also we saw and in Dharwad also we saw. So what happens if my plinth area is below road level is the water may rush into your home itself. So what we have to do is we have to always take care to provide at least 1 meter height from the existing road level. Your Hotsala, what we say or Katti, what starts at the start of your main door, it should be at least 1 meter above your ground level. So that is 1 meter, and next this is 3.05 10 feet into in, and this 6 inch I am considering approximately of your slab. Then anything else to add to this, or this is it? This is the total height. Anything else to add to this? Yes, I expect you guys to please write these down, otherwise you'll later forget. Above slab what? Flooring may not required, man. Flooring will come in 3.05 itself. It will hardly take around two or Extra length steel for, we are not calculating steel itself, man. We are not calculating steel. I want to understand what is the total height of the building. Yes, Ajay is right. Ajay and Rachna are right. Parapet. The parapet wall is around 1 meter height. The parapet wall is around 1 meter height. So you can see total height becomes how much, guys? Around 17 point something you will get. I can say it is around 17 feet. Correct? Now tell me what is the total length of column. Total length of the column will be equal to 1.5 which we have provided, that is depth of footing, plus 5.2. Correct? So 6.7 meter. Here guys, length of column. Yes, everyone is clear? Yes. Next, length of longitudinal reinforcement. So as you saw, apart from being length, there was some part bend at the bottom. Correct? That should be 0.45 at least. As per ISO it is 0.3, but it is always better to provide 0.45 plus 6.7. What is that 0.45 I think. Correct? You didn't get, many of people you didn't get. So I'll go back. Yes, everyone got what is that 0.45? Yes, this is that extra 0.45 that you have to consider. You are getting the column bars you can see here. These are extended by at least 0.45. As per IS code, this should extend for minimum 0.3. But here you can see it is extended up to, actually at this side it is extended up to 0.6 meters, that is 2 feet. Correct? So this bend bar, it should be actually 0.3. Even if you provide more, that is not a problem, but minimum should be 0.3. I hope it is clear, guys. So we were calculating total length of longitudinal bar. Correct? So total length of longitudinal bar is equal to 7.15 meter. I hope it is clear how we arrived at this 7.15. Yes, everybody? Next, transverse reinforcement, which are also called as ties. Now tell me, why are these ties required actually? Why we can't just, provide a longitudinal reinforcement and manage with that? It's not shear actually. Shear that is applicable in case of beam. Stirrups we provide to resist shear in beam. Okay, one reason is to hold bar in place. Correct. Bar should not move. That is correct. Holding bars is right. What is the next reason? Yes. Okay, it holds the bar. What is next reason? Now imagine what happens if I don't have like ties and I apply load. What will happen to main reinforcement? Those are going to bend, correct? Those will start bending. So basically the role of tie is to prevent buckling, correct? One role is to hold the bars in place because as we saw they are tall. They can't stand on their own. So these stirrups will give, ties will give again the stability, and also it holds the bars in place and also prevents buckling. Buckling, I hope you understood. With the application of load, the bars will try to move outside, correct? That is when buckling happens. Because of these stirrups, that buckling can be avoided. I hope the reason of ties is clear. Next, reinforcement. Let us say I am providing 8 numbers and I am providing spacing of 150 mm center to center, correct? Plan dimension, as I said, 0.23 by 38. Yes guys, is it okay how we calculated total length and how we are so now let us go to one example. Let us take one example. So 0.23 by 0.38. So tell me, how many bars are required for one column? How many bars are required for one column? One column I am having. How many bars are required? Correct here the 6 to 8 exact number of bars I want. So 6, I am asking you 12 meter bars. I am not asking you how many bars, means I am not asking how many cut bars. I am asking you how many 12 meter bars you will require for completing your one column of 12 dia 6 bars. How many full length bars you will require? I want to order now. I want to order 12 meter bars now. So how many bars I should order for one column? Yes, 4 bars I have to order or 5 bars? Okay. So how to calculate now? How do you calculate how many bars you will require? As you can see here, your total length of longitudinal bar required is 7.15 meter, right? So 7.15 meter. But what happens is, as per your what you can say is general rule, in ground floor building, lift is always half of 1 bar. First lift is always half of 1 bar, and second lift depends on the total height of the building, correct? In case of first floor, first lift is always 1/3 of 1 bar. So I'll tell you what is this. So what is this means? For example, 1 bar is 12 meter length, correct? So my first lift will be always of 6 meter. Clear guys? Yes. So to give me this, what is required? For the first lift, how many bars I require? Can I say 3 bars? I think many of you are not understanding. I'll explain once again. In ground floor building, first lift, when I say first lift, it is the first length that I place on the footing. Correct? It is the first length that I'll be placing. So the common practice is split 1 bar. Correct? split one bar of 12 meters exactly at half. That is how bar bending people will do. So if you are having 12 meter, they will exactly split at the end. That will create a 6-meter bar. In that 6 meter, for that 6 meter, if I cut this, how many bars it will be? If I cut this 1 bar, I will be getting 2 bars, correct? Correct? 12-meter bar I am having, one full length. If I cut this exactly at the half, I will be having 2 cut bars of 6 meter, correct? But what is my requirement? What is my requirement? I want for a first lift, I want how many bars? 6 meter bars. Clear? For the first lift, I want 6 meter bars. So from where I can get this 6 meter bars? That is, I can get from 3 full length bars. So this is little tricky. It is easy also if you understand. Just take your time and read it once again. It will be clear for you. Yes, please, everybody has to read it and tell me whether you understood or not. Yes, everybody has understood. And explaining once again, please listen. In ground floor, actually what happens is, our length of height is usually very high. Length of the building is very high. That is very high in the sense it is more than 6 meters, and we cannot provide full 12 meters also, because stability wise it will not stand. The column will not stand. So the usual practice is, instead of making like more than one cuts, what we do is we usually provide the first lift, the column which we make standing, which we do for standing is 6 meters. I'll just share with you. Okay, now is it clear? This first lift, what we were talking, this first lift, is it clear guys? This first lift, this is called first lift. That is the first point where I am starting my column. This is first lift. This will be 6 meters, correct? Including the bend I am telling. The length of this, yes, sorry guys, I hope you are clearly listening now. Am I audible now? Okay. I hope still many of you are not clear. So I wanted to show you this picture and explain. So this is my first lift, the point where my first erection of column starts. This is first lift. And by default, what we do is, instead of making many cuts here, if I may provide for 4 meter also. But what will happen if I provide 4 meter? Again one cut will be there, again one cut will be here. So what we usually do is, I cannot provide 12 meter full length, because it will not stand. Now only you can see at 6 meter only we are providing, here also you can see we are providing lateral supports. Here also you can see lateral supports, otherwise it will not stand. So 6 meters, it will also reduce our work in the same way, in the way of cutting and joining these, and it will also give stability wise good strength. So first, by default, including the bend, I am telling this including the bend. Including bend, the total height of this column will be, or the bars will be 6 meters by default. Clear guys now? Yes, is it clear? So one bar ಒಳಗೆ ನೀವು 2 bar generate ಮಾಡ್ತೀರಿ. So whatever may be the dia, you will be creating 2 bars. 2 cut length bars in one full bar. Clear? So our requirement is, I have to provide 6 bars, 12 mm dia bars, 6 bars. Correct? My requirement is I have to provide 12 diameter 6 bars. Correct? So to provide these 6 bars, my first lift has to be by default 6 meters. Correct? So what I have done is, I have to cut this and I will be getting 2 bars of 6 meters. So my total requirement is 6 bars. Correct? I want, for the first lift, I want 6 bars of 6 meters. So 6 bars of 6 meters, I can get it from 3 full length bars. 6 bars of 6 meters, I can get it from 3 full length bars. Is it clear guys now? Yeah, that fine adjustment you have to do. What Ravi is asking is right. That fine adjustment you have to do. I am only telling you to estimate it. Correct? If you are reducing 1 meter in one bar, next time you have to add 1 meter there. Correct? That adjustment you have to do at site. We are only trying to estimate the quantity here. Slight adjustments, those staggering and all, you can decide. If I am cutting one length less, then next time you have to add 1 meter more there. Correct? These type of adjustments you can do. Guys, this is clear till here? Is it clear till here? Yes, I want everybody to understand this. This is very important. I just want to share. First time I had got a big building and I did not know. I was also fresh at that point, so I did not know that first length is always 6 meters. The first lift is always 6 meters. So what I had done is, I had calculated and estimated for all the 7.15 meter. Correct? I had calculated steel for all the 7.15 and given at once. The required was only 6 meters, but I had given full length. So what happened? At side the bar were left unused for some time till the next lift came. Getting it? So first lift is always 6 meters. Depending on total height of the building, you can again estimate what else is required. Next, we'll come to first floor. In the first floor, instead of this, like cutting 2 bars in 1 bar, in first floor we do 1/3. That is, we do it 3 times. Why 3 times? Can anybody just tell me? If I do 3 times, I'll be getting 4 meters. So why I need 4 meter bar in first floor? Yes, I hope my question is clear. Why I am not going for 6 meter bar in first floor? Why I am going for 4 meter bar? Okay, so total length, let us just check what it comes to be. Since I am starting from slab to slab, I will be having 10 feet height plus my parapet. Any other thing to add to this? Anything else to add to this? Yes, Vasant, Bharat, you are right. Footing is not there. So anything else to add to this? No, because it is just my parapet height and it is just my floor height. That is 10 feet. So what we do is, we cut 12 meter bars in 3 pieces of each 4 meter. So how many bars are required to complete this? So how many bars are required to complete this? Yes, correct. 2 bars. Correct. Now there are many ways of calculating this. Let us see. The one way is you have to use your brain. The other way is you have to use just your calculator. Let us see how. Okay, so what you can do is, when I say 4 meter bars, when I say 4 meter bars, how many bars are required? 4 meters? 6 bars, correct? Yes or no? My requirement is 12 diameter, 6 bars, column diameter, column reinforcement. Each has to be 4 meters. So how many it is? Total length is 24 meter, correct? So what is length of one big bar? 12 meter is equal to 2 bars. I hope I am clear. This is one simple way. The other way around, what you can do is, for example, in the first lift, you know that you have to provide 12 dia, 6 bars, correct? You can directly divide this 6 by 3 and it will give you 2 bars. Understood? Why I am doing this 3? Why I am doing this 3? Because in one bar I am cutting 3 times. That is, from one bar I am generating 3 cut bars. Clear? Here also you can do the same way. Here also you can do the same way. You can just directly divide it by 2. You want 12 diameter, 6 bars of 6 meter. Here also you can do the same way. You can directly cut correct. Why I am telling you these shortcuts is, people will ask you directly, correct? So now let us estimate. We'll do a small estimate. What we'll do is, I am having 3 columns with 16 dia bars, 8 bars, and 2 columns with 12 dia, 4 bars. So in the first case, how many bars are required for the ground floor one? If I am constructing a ground floor building, how many bars are required here? If I am constructing a ground floor building, how many bars are required here? I am asking for first floor only. First lift I am asking. So many of you are getting still confused. When I say first lift is of 6 meter height. Please always remember this. Okay. Now we will calculate in this for 2 ways that I told. Correct? 8 bars are there. Correct? 8 bars are there, and each bar is of 6 meter height. Correct? So how much you will get? 48, and each full length bar is of 12 meter. So you will be getting 4 bars. Tell me if anyone is having any doubt in this first method. Yes, anybody is having any doubt in this first method? Okay, one more, as we saw, I need total 8 bars, correct? This I am going to directly divide by 2, correct? So I will be getting 4 bars. Why I am dividing it by 2? Because 6 meter is half of 12 meter. Getting? So now tell me how many bars required here in the second case. Either you can calculate full length, total length divided by 12, or you can directly do the second way also. So how many bars are required for the second case? Yes, 2 bars. Clear? I hope it is clear. Next, in other case, I have one column having mixture of diameters. 16 mm 4 bars I am having, and 12 mm 2 bars I am having. So tell me how much steel I require for first lift. How many 16 bars are required? How many 12 bars? Yes, it can happen that you may get a mixture of bars. 16 mm and 12 mm you may have mixture. Yes, I want diameter with bars. Which diameter? How many bars you have to tell me. Yes, right. 16 mm you will be having 2 and 12 mm you have to order 1. Correct. Yes, this was for first lift. Now what about second lift? How to calculate the second lift? Yes guys, what about second lift? For the same setup, how many bars are required for second lift? Can anybody just tell me?